Hello, Year 9, and here we are at the end of another week of maths. Um, I've been really impressed with the submissions. I'm making this on Tuesday, so I haven't seen any submissions from Tuesday's lesson, but Monday, where I sent you that little puzzle with the square broken into shapes, I was really impressed, and well done. Lots of you clearly coping very well with this. I need to make it a little bit trickier. So we're going to talk today. Yesterday we were talking about converting fractions to decimals. But we were sticking with easier ones. And so what I'm going to deal with today are harder fractions, converting them to decimals. I want to talk firstly about what sort of fractions, what sort of decimals you get from fractions. So when you convert a fraction to a decimal, it always falls into one of two categories. It's always what we call a terminating decimal, and that's one that finishes, doesn't need to be rounded. So a quarter is 0.25, 1/16, 0.0625. They're not rounded, that's just the end of the decimal. So it's either a terminating decimal or it's a recurring decimal. So some of you will remember that 1/3 is 0.33333, which we write like this. But you get all sorts of weird and wacky recurrences. So for example, a 12th, if you look at that, you get 0.0833333. So the 8 isn't repeating and the 0 isn't repeating, but the 3 is. Can you see how we write that? So we just put a dot above the 3. And then some fractions recur in an amazing way. 1/7, for example, this is what it looks like as a decimal, and it just looks like a proper mess. But if you look carefully, you'll see that the pattern 142857 is repeating 142857, and there's the start of the next one. So we write it like this, with a dot at the beginning and at the end of the bit that's recurring. So we look at two methods for changing harder fractions into decimals, and the first uses a calculator. Now, some of you will have your own calculator, some of you will have to use your phones. It will work either way. So for example, if I want to change 2/5 to a decimal, I've got two options. If you've got a calculator, you can use the fraction button and type it in, and then just press equals and S to D. If you haven't got a calculator, it's okay. You can just divide it. So you can do numerator divided by denominator, because we're already used to algebra that we write division like this. So 1 divided by 8 and S to D, you get exactly the same answer as using the fraction button. Sometimes you're going to get recurring ones, so 5/9, 5 divided by 9, S to D. So my calculator has sorted out the recurring notation for me. If you did that on your phone, you would see 0.55555, and you'd be expected to understand that that meant that. And if it's a mixed number, well, I'm not going to bother about the 3. I know that's going to be 3 point something. So all I'm going to do is to do the 5/8 as a decimal. S to D, 0.625. So 3 and 5/8 would be 3.625. So this is really easy, this first bit. I'm sure you will have no problems with that. Let's have a little practice. Okay, so here are 8 fractions for you to change to decimals using the technique of the calculator. Have a go at those, pause, and come back when you've done it. So if you've got your own scientific calculator, this is so much easier. It does all the recurring stuff for you. If you're using a phone calculator, hopefully you're still able to spot the recurring ones. So the top ones, hopefully, sorry, I just realised I made a mistake there. That's 2.125, sorry, 2.125. Well done if you were able to do those without your calculator, because those are easy ones like we were doing yesterday. But then you got to the recurring ones. So on a phone calculator, that would have said 0.44444, which is 0.4 recurring. Here we've got 0.2666666. So the 2 doesn't repeat, the 6 does. So we don't have a dot over the 2, just over the 6. This is a great one. You get 0.1234, 1234, 1234, 1234. So that's a dot over the 1 and a dot over the 4. You mark the beginning and the end of the recurring pattern. And then 8/3, top of your fraction, calculator still deals with it. That's 2.6 recurring. Some of your calculators, particularly on a phone, might have written it like this, with a 7 at the end, and that's because some calculators, they show you as many digits as they can, and then they round. So the next digit was a 6, so they would have rounded that up to a 7, but it's not that. The 6 would go on forever, provided you had an infinitely long calculator screen. Okay, so let's sticking with our calculator, let's now use it in a practical way. So we're asked to put these lists of fractions in order by using decimals. So I'm going to do the first one for you. I'm going to change all of these into decimals. So I can either use the fraction button or just divide. So this is 0.581. Now this is a weird one. Look, it starts repeating there. Wow. And finishes repeating there. Now, I'm not going to write all that down. So I'm going to write down 4 digits, and I'm going to round it to 4 decimal places. So that would be, I might need to be more accurate, we shall see, but that's rounded to 4 decimal places. Okay, let's try the next one. Okay, so that's 0.54375. So if I've now decided to go to 4 decimal places, that's 5437, but the next digit is a 5, so that's 5438. And then 196 divided by 360. And that's 0.54 recurring, so to 4 decimal places that would be... Okay, so I've chosen to round to 4 decimal places, and I've written all of them at 4 decimal places. So this is a recurring one. This one went on another digit. This one went on for ages. But by rounding them all, it's easy to compare them, isn't it? I can easily see now that this one here is the smallest. So that came from that. So my first fraction in the list is that. And then this would be next. So that came from that fraction. And then the last one would be the biggest. Okay, can I get you to pause the video and have a go at those other two? Change them to decimals. Decide how many decimal places. 4 is a good one. Just 4 decimal places. You might decide you don't need 4 when you look at all the fractions, and then use that to put the fractions in order, smallest to biggest. Pause and have a go. So we had some really weird and wacky recurring patterns here. So this one, 6799, gave you 0.96969696, 0.96 recurring. When I rounded that to 4 decimal places, the last 6 rounded up to a 7. This was one of those ones that had a long recurring pattern, so I just wrote the first 4 digits of that. And this one I was at 0.838383, so that rounds to that. I'm only using rounding because I'm being asked to put them in order and I want to compare them. Up here, didn't round. I used the recurring notation. So if you're asked to write it as a decimal, use the recurring notation with the dots. The only reason I'm rounding here is because all I want to do is compare them. So now I've got them all with the same number of decimal places, it's easy to compare them. So I can see that one's the smallest, 5/6, that one's the next, 16/17, and then that was the biggest. Similarly here, I only rounded them because I wanted to compare them. That's clearly the smallest, the middle one, 13/9. Not much in it with these two, but 1.4808 is just smaller, so that's 77/52, and that's that one. Well done if you managed to get that. So one way of converting harder fractions to decimals is with a calculator. Okay, so the non-calculator method, and I'm delighted about this, you know how I love my Monday numeracy starters, use the bus stop. So a moment ago when we were using our calculator, we either used the fraction button or we divided it out, 1 divided by 8, because this thing can either mean 1/8, the fraction 1/8, but it can also mean 1 divided by 8. The two things mean the same. So if I think about this as 1 divided by 8, I could do this as a bus stop sum. You've got to be careful you get it the right way round, because the number that we are dividing goes underneath the bus stop, and the number we are dividing by goes outside the bus stop. Now, because this is a nonsense sum, how many 8s are there in 1? Well, there aren't any. But remember what we can do with bus stop when we have decimals. I can add as many zeros as I want here. So let's add 4, and I'm going to put my decimal place up in my answer. Because I'm dividing by 8, I'm also going to write out my 8 times table just to help me out, just to speed things up. 56, 64, hopefully I won't need to go further than that, we'll see. So how many 8s in 1? There are no 8s in 1, so I'm going to carry the 1 forward. How many 8s are there in 10? Ah, right, there's 1 8 in 10 with 2 left over. How many 8s in 20? Well, I haven't got enough for 3 8s, I'd need 24, but 2 8s are 16. I've got 20, so I've got 4 left over. How many 8s in 40? Well, that's exactly 5 8s with no remainder. No remainder, so the sum stops. So 1/8 as a decimal is 0.125. Now the great thing about you watching this on a video means you can rewind that and have another look as many times as you want. And I know a lot of you find the bus stop thing a bit confusing, so this is your opportunity to really get this clear in your mind. So why don't you rewind it and have a go, just to see and watch. I'm going to give you some practice in a minute, but yeah, this is your opportunity. Right, 3/11. So I can think about that as 3 divided by 11. 3 divided by 11. It looks like a nonsense sum, but let's add some some zeros and a decimal point, not forgetting the decimal point in the answer. And I'm going to, well, hopefully your 11 times table you're pretty okay with. It's the easiest one to remember, isn't it? Well, maybe the 10s are the easiest, I don't know. How many 11s in 3? There aren't any. So there are no 11s in 3. I have to carry that 3 forward. How many 11s in 30? Well, I haven't got enough for 3 11s, so I've only got enough for 2 11s. 2 11s are 22, so I've got 8 left over. How many 11s in 80? Well, I've got 7 11s are 77, so that's 3 left over. How many 8s in 30? Sorry, not any 8s. How many 11s in 30? Well, I haven't got enough for 3 11s, so it's 2 11s, which are 22, with 8 left over. Hang on a minute, what's going on here? Can you see what's going to happen? 11s in 80, well, that's 7 11s with 3 left over. That's going to repeat, isn't it? So what we've got is that 3 11ths is 0.27272727. 0.27 recurring. Now, if you hadn't spotted that and gone on and on and on and on, you would have made an awful lot of work for yourself. So we've always got to be on your toes when you're using this method, looking out for a pattern that is repeating. Again, if I went too quick there, good news. Pause the video, rewind it, watch it again. Okay, can I give you some practice ones to try? Okay, so can you use the bus stop method to change 7/8 into a decimal, 1/6 into a decimal, and 1/11 into a decimal? Remember, you've got to get the numbers the right way round. I'll start the first one for you. It's 7 divided by 8. If you put the 8 there and the 7 there, you'd be doing a completely different sum. Now, I want you to take this seriously because you know, it would be very easy for you at this point not to pause and just run the video through and have a look at the answers. But it's really important that you understand this. So I've left my previous answers up there. Pause the video now and see if you can get somewhere with those 3 fraction to decimal conversions. So, did you have a go and get these? Well done if you did. So I had how many 8s in 7? There are none to carry the 7 forward. How many 8s in 70? 8 7s are 64. So that left me with 6 remainder. How many 8s in 60? Well, 7 8s are 56. So that left me with a remainder of 4. How many 8s in 40? Exactly 5. End of. So 0.875. That was a terminating decimal. 1/6. How many 6s in 1? There aren't any, so carry the 1 forward. How many 6s in 10? Well, that's 1 6 with 4 left over. How many 6s in 40? Well, 6 6s are 36, so that's 6 6s with 4 left over. And then you keep getting 4 left over, and that's how we write it. Remember, the 1 isn't recurring, the 6 is, so we just have a dot over the 6. And I don't know if you've ever come across this before, where you get more than, we get a 2-digit carry forward. So we had how many 11s in 1? Obviously there aren't any, so we carried the 1 forward. How many 11s in 10? Well, there still aren't any. So I put a 0 there, and I have to carry the 10 forward. How many 11s in 100? Well, 9 11s is 99, so 9 11s with 1 left over. Same problem again. How many 11s in 10? Well, there aren't any, so I carry the 10 forward. How many 11s in 100? 9 with 1 left over. So what you get is 0 9 0 9 0 9. So the 0 and the 9 are repeating, so that's why we had 2 dots in that situation. So here's your question for submission. I'd like you to use that bus stop method to change 7/15ths into a decimal. Of course, the good news is that you can use your calculator to check the answer. So you can work out what the answer is going to be using your calculator. Just either use the fraction button or do 7 divided by 15. I want to see the bus stop though, so don't just write 7/15ths equals and tell me the answer. Anyone can do that with a calculator. I'd like to see a bus stop. Can I just at this point take my hat off to everyone who is submitting work regularly. Some people are submitting it first thing in the morning on the day of the lesson, which is brilliant to see. And keeping up with these lessons rather than letting them build up and trying to do them all in one go is the way to do it. Just try and keep in your usual school routine. It's not ideal, none of us like it, but sitting there and doing nothing, pretending it's going to go away, that's not going to help you. We've started GCSE, so we really can't afford to miss lessons, let alone weeks and groups of weeks. So well done to those that are keeping on top. If you are a little behind and you are submitting work from the previous week, so say you're watching this not in the week that it's set, it's the 20th today, but following week, can you submit it by email rather than on class charts? If you're doing this on the day it's supposed to be done or in the week it's supposed to be done, then use class charts, that's fine. But I'm not looking back at class charts for previous weeks. And the other thing is, if you've done work and submitted it, brilliant, it's so great to see. But don't forget to go back and have a look at what I've written, because sometimes people make mistakes. So yeah, please make sure you go back and check your feedback. Okay, take care. I hope you're all staying safe.